Thank you for the confirmation. So I think we are a bit late today, delaying a little bit anyway. So my talk is mainly inspired on one of our research funded project, and in that we proposed a framework, and that framework is known as a HAL framework, which is a hybrid adaptive reinforcement learning based framework for smart home application scheduling. And that's the demand of in the SDG, also like the sustainability development goals. And we are doing a kind of energy optimization under this particular project, and that's the title of the project. So now moving forward, so the top points are like the research motivation of this project, and the problem statement and what we are doing in this framework, right, to make energy efficient structure, and of course the privacy, and the confidentiality is another key pillar in that. And then, of course, the research contribution and how we, evaluated our framework, following by the final remarks. So I don't want to take much time. So let's start with the motivation of this project, basically. And we all know, like after the advancement of these fifth generation networks and all that, and high speed computing devices. So this digital, or like the smart infrastructure is highly demanding, right? So, and everyone is looking for like smart home, smart infrastructure. And if this is the case, then of course we need to look for certain solutions, certain intelligent solutions that provide like efficient scheduling, efficient energy management, efficient you can say the decision making capabilities for these smart devices. And all of these devices are like, you can say the sensory based devices, and of course like all these sensory based devices are based on the IoT enabled hardware, or the infrastructure. And that's why we need lower electricity bills, right? We need like intelligent decisions taken by all these devices, so that of course it's going to improve the comfort of everyone. So smart home, smart and this project is basically for the smart homes, you can say, right? And of course we want to automate everything, and we want to make our localized control in a better way, to utilize whatever be the resources or like the smart appliances we have at home. And the existing methods, this lacks the adaptability and privacy safeguard also. And of course all these sensory devices going to exchange the data, right, going to receive and send the signals or sensory data, and of course connect it to the network. And this makes all these devices highly vulnerable for a specific type of cyber attacks. And the idea is that, so we also need to think in that direction, so that we can protect whatever with the data is being generated or received by all these appliances in home. And there are like so many cases in the history of cybersecurity, right? So the problem statements of smart homes generate highly frequency sensitive data, as I mentioned. So no matter like whatever be the devices you have, that includes all your refrigerators, you can say, the washing machines, you can say the smart appliances, you can say the smart TVs, you can say, or like smart ACs nowadays there, right? Smart fans are there. I mean, whatever these sensitive devices are there, so these devices generate highly sensitive data. And that's why, I mean, if we are going to implement automated decision maker or a kind of scheduler, then uh, this helps us to save the energy. Also, I mean, and also like through the forecasting capabilities, we can understand our consumptions in our home. Okay, and no privacy preserving mechanisms for like the traditional schedulers, but this one in our project. So we are implementing a kind of reinforcement learning based smart scheduler. And that's why we need a secure and adaptive and data driven scheduling solution. And that's the main motivation. And the aim of the project is to use the real time sensory data. So we are capturing real time data, and then we are estimating a kind of forecast. Okay, and also like what appliances need to schedule at what time, what appliances need to switch on, switch off, energy consumptions and all that. So that is based on the real time analysis. And of course, as it's adaptive reinforcement learning, so we have certain actors that up to that particular environmental context. I mean, in the home, what type of environment is there, how many occupancy is there, right? So it is based on that. So and based on the environmental factors, it's going to make precise decisions. Of course, it helps to optimize the energy usage and the cost. And another thing is that it ensures the privacy using the encryption and secret sharing. So this is what we are using in this project. So for a security perspective, for data security, we are following certain compliances. Of course, the encryption is there, so it's a AES-based encryption, and we are also implementing homomorphic encryption to generate or like to implement this privacy to secret sharing. And of course, it maintains the user comfort. I mean, these are some of the aims under this project, and the project is still in consideration, still going on. So it's the proposed framework is a kind of five-stage secure RL or reinforcement learning-based scheduling pipelining, and we use to train the model. We use the kind of UKDL data set, and with the integration of like activity recognition, energy forecasting on the dashboard, right? And then of course, with the help of this framework, we are able to detect any kind of intrusions if they are in the network, or like if someone is trying to attack on your IoT or like these sensory devices. So that's also be one of the part in this project. And then of course through the DQ and the deep Q networks and the PPU proximity optimizers, we are going to achieve all that. And then we are combining with the multi-layer perceptron model for REST friendly deployment. And we can see like from the results that the proposed framework is outperforming compared to other like these AI and machine learning models, as well as the if you are implementing simple multi-layer perceptron model. So still like this under this framework we achieve like 99% accuracy, and that's how we compare with other models as well. So this is the overall framework. Okay, so here you can say we have smart home, and different devices are there, right? Smart devices that we have. And then the first step, I mean, because the time constraint, let me explain the figure at everything here. So the first stage is about to encrypt the data. So here we have like more about the privacy preserving, and then homomorphic encryption we applied through script sharing based scheme. It's not a kind of a scheme. In conventional secret sharing, the share is going to be encrypted and going to be embedded, and likewise, the encryption performed. But this is a morphic encryption, so the data is already encrypted, and then we have to, we have to do a kind of encryption on top of it through, or like by generating different shares. And that's how this encryption over encryption, so that brings like more privacy, and that's why we have this fully homomorphic encryption. And then the data is going to be stored on the cloud, and then further like from the next step, the data is going to be processed, right? So we performed a normalization and scaling, because different features are there in terms of like the temperature, or the energy consumption, so the voltage and everything. So sometimes these values are quite noisy, and we are doing a kind of pre-processing over it through the scaling and all that. So it's if the scaling is good, the model is performing in a better way. So the idea is that, so that helps to make intelligent decisions by the model. And then whatever be the output, so it's going to be fed to the reinforcement learning model. We have the MLP mode. The agent is there, the action, and different states as per the choices are there, or based on the appliances we have different states. The agent is going to look into the environment, and then going to perform certain set of actions, whether switch off the light, or set the thermostat, or turn on the cameras, or turn on the AC, and so on and so on. So different actions are there. So and that's completely how the agent is going to learn from that environment, and it's based on that. And then of course certain rewards and penalties are there. That's part of the action. And then finally, whatever be the results is going to produce, so we have a data flow forecast on the data analysis, as the data forecast going to be displayed on the screen, so where the user can see can monitor the usage of the power consumption, usage of the data usage of or for security perspective also. It's very cost effective, as well as like if any intrusions going on and not. So this is a kind of this is a framework for the proposed proposed approach. So the first one is smart home
खाना खाने
data
नहीं आओगे
generation.
ना?
Of course, these smart devices continuously
अरे
generate operational data.
अब
The
खाने की
sources
पैसे
might
नहीं लाया हूँ, मेरे तो
include
खाना ही लेके रखा है,
lights,
लेकिन
fridge,
यहाँ
AC
रिकॉर्डिंग कर
cameras,
रहा हूँ मैं।
microwave, and in case if you have any other
ये
appliances.
एक
So
सेशन चल रहा
those
है।
appliances are going to be there. And then we, in the
तो ये
second
पेपर
step, as I
प्रेजेंटेशन वाला चल
mentioned,
रहा
so
है ना,
data
उसका
encryption
रिकॉर्डिंग
layer.
लगा के
So we
रखा हूँ यहाँ पे
perform
मैं।
the homomorphic encryptions where the
तो
secret
बन गई होगी इसमें
is
तो
going to be generated, and then encrypt all the home data
यहाँ
before
पर।
leaving the home or
लाइट
before
गोल हुई,
it's
कुछ
it's
भी
going
हुआ
to be
तो बंद
stored
हो
on the
जाता है, वो
cloud,
चेक करना
and
पड़ेगा।
that's how that's how we are going to produce. I mean, in
जी
the
आ जाओ, मैं भी
homomorphic encryption, so ciphertext is being generated from a
आ
ciphertext. You
जाओ
can
आ
say,
जाओ,
I mean,
उसको
it's a
याद है
kind
ना
of
मैं किधर रिकॉर्ड
double
कर रहा हूँ करके।
encryption. And yeah, it's based on
कमलेश सर
state
नहीं है यहाँ पे
sharing.
अभी?
So encrypted data splits into multiple state shares and
कमलेश सर के ऊपर
distributed
लगा
for
दे रहे
the
हैं कॉल।
computation. So no
मनोज सर लगा
user
दे रहे
can.
हैं।
I mean, this brings more
ठीक
privacy,
है।
more
हाँ।
confidentiality, basically.
नहीं नहीं,
So I mean,
कर दो,
if
मेरे
you
को
have access
बॉक्स
to
में चाहिए, मैं नीचे मनोज
one
सर से
of the
लेके
secret
आऊँगा।
share, you
हाँ
can't
बताओ।
generate the key. So the idea in
ऊपर आओ
conventional
कमान,
secret sharing scheme, so you
ऊपर आओ।
can you
मेरा लंच
if
बॉक्स
user
वहाँ पे
knows
है, गाड़ी में है।
different
मैं
secret
आज
shares,
पानी में भीगने के
they
चक्कर में
can
अलग रख के लाया था।
decrypt that. But here is not
मैं
the
ले आऊँगा।
case. So because the
आ जाओ।
users are not aware about like which shares they have. For example, let's say if the power consumption is in
बहुत
100
ठंडा
kilowatt,
पड़ता है भाई।
so one of the appliance is going to consume 40,
बहुत
another
ज़्यादा
appliance
ठंडा
is
पड़ रहा
going
है
to
इसमें।
consume like 20, and the another is going to consume 30. So they don't know about like, okay, it's total
महेश भाई
100.
यहाँ पे
So
पूछ
that's
लिया
how
था,
the
मैं
secret
खाने का
sharing
इंतजाम कभी किसी
brings
का नहीं होता है।
more privacy
मैं
in
तो
this
जिस दिन
particular
पेपर लीक नहीं
model.
होने तो अपना खाना नहीं खाया,
And
वैसे
there is
यहाँ पे आके
no
पूछ रहा
data
है।
exposure, so no one knows about the actual data.
नहीं,
So that is
उससे
the
पहले
beauty
क्यों
of
पूछते हैं?
this encryption.
भरोसा नहीं रहता है। क्या बोलते हैं?
And then of course
खाना कम कर दिया,
the data is
तो मैं
going
अपना
to be
खाना लेके
stored
आऊँगा, जो नौटंकी मत कीजिए।
in or on the cloud for and of course we implemented access control and policy compliance is there, policy compliances are there, rules are there, right? And of course it prevents the unauthorized access,
ये लाइन नहीं मार देता
and
डब्बा।
whatever be storage is there, so it's complied with
ये
respect to the
इमेज ज़्यादा होगा,
GDPR
इस पे राइट
or
क्लिक
the
करेगा तो
DPDP,
बॉक्स आ
so
जाता है,
and
फिर इस पे राइट
different
करेंगे।
compliances.
जैसे कैसे मैं
Now data
कस्टर्ड
acquisition.
कर
So
रहा
I mean,
है,
useful
चिक्कू डाल
features we
दे।
have to extract from the data for real-time schedule, and then of course
ये
we have to
इमेज है ना,
forward
इसके ऊपर
whatever
राइट
be
क्लिक करना, आई
the
थिंक आ
features are
जाएगा।
there for the next module, and
बॉक्स बनाने के लिए
cleaning up
विंडोज
is
10 का
there.
ऊपर डाल
The
दिया था,
processing,
मार्जिन
normalization,
10
scale
कर दिया।
values,
क्या?
extract useful features like the hours, occupancy, device state, and all that. And then finally, after
कलर मेरा
applying
कलर में रख,
the
ब्लैक एंड व्हाइट पे
model
रखना, ब्लैक एंड व्हाइट पे रख
or
देंगे
this RL approach, then we can
वैसे
do
यूजुअली
kind of
बोलती है
data
कलर
analysis
लिख
and
के जमा
forecasting.
करना। तुम अपनी कॉपी में क्या
Okay,
लिखोगे बाद में
so
समझ
this
जाते
is
हैं। ये
another
बोलती है
thing.
इनको जमा कर रहे हो तो कलर
And
कौन सा
this
लिखोगे?
is the reinforcement
ऊपर
learning
का
model.
उसको
So
ऊपर
DRL
रखना,
algorithms, we use the PPQ,
एक
DQ, and
नीचे
A2,
रखना।
C, and SX because these algorithms are very good in terms of
तुम्हारे पास
like
जितना पैसा
dynamic
होगा तुम खुद ही
adaptation
मान
and
लो
all
अगर
that
मान
for all
मान लो तो।
appliances. So that's why we picked all these. And and like
हर
for
चैप्टर
like
के बाद
real
सबसे
time
बटन वाला
decision
पेज
making,
निकलेगा।
it is very effective, makes the
वो
model
निकाल दिया।
or makes the model like very intelligent to learn. And then of course different action or control states are there,
पेपर कंप्लीट
actions
कर
and
दिया तो
state, and based on
ये पूरा ही सब है,
the
इसमें
states the
दिखाना
action
है।
is going to be executed,
इसको
and of
रीसेट
course
करना
the
है, तो इसको मैं क्या करूँ
reward
बताओ?
and penalty in terms of like how the policy or the policy is going to be updated based on the rules.
रख लो।
Okay, so this is there, and then of course the initialization agent environment. That's the first step of
वो दिन
the
नाम लिख रहा
implementation
है
of
और
this
सेंटर में आ रहा है
reinforcement learning.
ये।
So this is how it is, and
हाँ ठीक है,
then of
वही तो
course
उसी बटन पे छपा
this training
है।
loops will take up, right? For agent
ये
observe the
नीचे है,
states, going to perform the
या
action,
ऊपर आएगा।
going to look into the
पूरा समझ
environment
में आ जाएगा,
updates and
स्क्रीन
all
छोटा
that, and
करना
generate a new state.
साइज
So
का,
we have to
टिक को
reduce
आएगा,
the
ठीक है।
temperature, we have to turn on the fan and all that, and of course, and then it's going to be updated based on the environmental changes within the smart home, and then it's going to repeat until a convergence occur, or like optimal control strategy learned by the model.
सारी पूरी चीज़ बॉन्ड पे निकलेगी।
Some of the actions that we are
लिस्ट ऑफ
going to
एक्टिवेशन,
execute in this, I mean, yeah, just an example. So turn on the light and
लिस्ट ऑफ
light on
फीचर्स
or off,
किधर है?
adjust the AC levels, thermostats and all that, control fan speed, switch device
अवेलेबल भी
intelligently.
नहीं तेरे पास, एक अवेलेबल
So
भी
I
तो होगा ना,
mean,
दो
if
तीन
you
जगह
are
पे।
even like at home, so you are at home, or
टेबल
let's
क्या
say
लेना
away
है?
from the home, still you can through that
हैं?
application you can
क्यों?
manage these
यहाँ टेबल
intelligent
पे तो डेटा
devices.
और एल्गोरिथम का
And
दिखा
the
रहा
main objective
है।
is
डेटा
to
दिखा रहा
make
होगा।
sure that there are energy
डेटा की तो
savings,
टेबल तो
right?
होगा
Energy
भाई।
savings and the comfort for everyone, and of course brings more
डेटा क्या
efficiency
था
in terms
तेरा?
of
क्या तेरा प्रोजेक्ट क्या है?
scheduling these intelligent appliances
इसके सेक्शन
home,
क्लिक
right,
करके
at
पुराना
home.
डेटा भी तो डाला होगा।
So now the last
टेबल
is
चेंज दिखा रहा है
data
यहाँ पे, टेबल
monitoring
डाला है।
dashboard, so that visualize the data in real time, forecast versus the actual value. So here also like we have the sensory notes, and based on the forecast we can expect like the consumptions monthly basis, weekly basis, and all that. So similar kind of approach that we followed in this project as well, that helps to improve the energy performances. And the decisions are in real time, and decisions are very good. So the accuracy of the model is very good. They are performing out, performing in a better way compared to the other algorithms, and helps the operators to track system behaviors, right? So like, also, this helps in troubleshooting the devices as well. So it's a cost-effective evaluation. So we compared the framework with the pre-RL versus the post-RL energy usage. Before implementing this reinforcement learning model for smart scheduling, and we observed this thing that, yeah, there are like a lot of energy usage because the appliances are going to change their states. Depends like on the environmental conditions within the home, and this helps us to save money. This helps us to save the energy, which that's very important. Of course, it reduces the cost also. And final evaluation of smart home optimization. So optimization is going to be done with the help of the PPU. So DQN. So this is the deep network. Neural network. So energy consumption stability is in the model is from like 2.15 to 2.33 kilowatt, and very low cost fluctuation. So highly reliable for device scheduling and stable control, and that's the reason that we used this RL model. And then also have the PPO for dynamic adaptability, so better flexibility and smooth policy adoption. So this gives a higher classification performance, as you can see. It's around like 93% AUC ROC, and effective for context-aware adaptive scheduling based on the states. And of course, the both the DQ and PPU performs well on the sleep active and idle states of the devices. So that's how, and that's the comparison compared to like some other conventional machine learning models. And we can see that energy is highly optimized, or at a moderate level, you can see. And accuracy is 99%. The speed is very high. So within the microsecond, you can see 3.1. So we optimize the speed as well. And model size. So the model size in terms of like, as it's a as based concept also. So it's very small. So it's comparatively small compared to other conventional models. And of course, for the security concerns, we use the AEC and ECC based encryption, and also like the data is stored in the cloud. So we implemented rollback as well as the attribute based or like attribute based access controls over there, right? And sports the anomaly detection and secure device communications through these all secure implementations. And of course, we can see from the dashboard and can detect all the intrusions if something is happening within the environment or within the smart home. So the conclusion, so this project provides a unified secure and intelligent framework for smart home automation, and which combines sequence stability with PPQ for like real-time optimized scheduling and then energy efficiency. Of course, the security is on top of it. And this multi-layer perceptron based like hybrid approach is best for real-time deployment with the accuracy of 99%. Fast inference speed is very fast, and it's a small model size. So compared to like other models, we can easily deploy it. And all the HAL delivers energy saving, user comfort, low latency, and strong security, making it a practical solution for modern smart homes. We have this framework ready with us, so we have a kind of prototype, and we implemented this so far. And yeah, this is quite satisfactory, and the part of the university grant FC121, under which the project was implemented successfully. And yeah, there are some of the references, as we have limited time, so that's why I have to be kind of rushed because of some prior meetings now. So, and okay, now so finally you can say the energy efficiency is not a choice anymore. So it's everyone's responsibility to manage the energy in an efficient way, and it's a new definition of smart homes or smart infrastructure. So thank you very much for listening. So I'm open for any questions. If you have any questions, please, I'm more than happy to answer.